the 8th Azure Bootcamp we are conducting here in Singapore. And today's session, I'm focusing on infusing intelligent search capabilities into your applications. So this is a dev track, and what we discuss today will be specific to you as a developer. How does that impact you? What experiences that you can drive? So before we get on, a quick shout to our organizers who are recording this on YouTube and making sure that we are safe and we are still keeping on learning. So thanks to the organizers to keep up the momentum. On the agenda today, we have a bit on evolution of apps, why search required, what is really search, how to configure and how to use it. So this is where I pause for a minute. There's a QR code for feedback so that we can improve. There are important links that you can kind of take a screenshot of, and either you can follow along the presentation or you can download and look at the code later on. Moving on. So if we start from what happened in the 1980s, PCs were first introduced to us. And very quickly, we moved on to the momentum of internet in the 90s, where we searched the websites a bit differently than we do today. We visited websites, and that is what our core experience was. In the 2000s, we saw social media and user downloaded apps from the app stores playing the most of the motion around how the applications changed. With that, we had different architectures supporting us, client server, SOA-based architectures, and all those things were very much into momentum in the 2000s, primarily because of the momentum of internet and mobile and the client server computing. In this era, we're talking about intelligent applications. So when we talk about intelligent applications, we're bringing in the user centricity into the picture. We're saying apps are intelligent because they consider users' behavior, users' preferences when they help do the needful work. They're also data-driven decisions. Now, 2 years ago in the same bootcamp, I'd spoken about bots, which was a user-centric, intelligent, conversational way to interact. In today's session, we're talking about data-driven decisions. How do you really use data to ease and bring that user centricity in your applications? A lot of my colleagues are going to speak about cognitive services. As a developer, this is your first homepage on how do you bring intelligence into your applications. It has various facets. It comes with vision, speech, language, knowledge, search, and some of the beta things that even Microsoft is working on. When you talk about vision and speech, we are talking about detecting something that happens either through camera or through the microphone. It could mean, emotion recognition of people who are coming in and going out of the conference. We had demoed this a couple of years ago. It could mean speech. If you remember, we had captured a speech-based bot that could translate whatever you're speaking and then understand the context and reply back accordingly. With that comes the language. We need to understand the language in which the user is speaking, extract the keywords from it, and then be able to go into the knowledge. We use this extracted information and then search the knowledge. We get the knowledge relevant to it. So when we try to get this knowledge, relevant knowledge, what are we trying to do is actually providing a search capability or a matching capability on the knowledge. Now, if you look at the story that I just told you about, we started with vision and speech being the enablers of the new experience, the language being the tools, the knowledge being the ultimate data that gets used, and search being the facade that facilitates this retrieval of knowledge and providing the information back to the end users. So when we talk about search, what exactly is search and why is it really important? So a long time ago, when we were developing applications, we would have a very big, screen that allowed with a lot of filters on the page to say select a category, select the product, select the catalog. Different kind of applications, the filters would change, but essentially we would have a way to filter the data, and then we click the button submit. It would bring back the data to us. Now that's the usual enterprise application behavior that we all have seen. And that would eventually would have a SQL backend, whether it's MS SQL or some other SQL, but would eventually do a query on the database. Now that's smaller data set, not an issue, and the experience is actually very much driven to what we want others, the end users to do. We have specific filters that the users can type into, and we have specific queries for each filter that we have to really search for. So when any change comes in, we have to actually manage the front end, the back end, and also the database. Now it's difficult to bring an experience which is search driven. If you imagine a search experience like this in your application, where you have a bar and you ask the person to type in, and then you get the relevant data based on that, that is tough until now. That was something that would require free text searches into your database, that would require free text queries into different tables, and it would be a little bit cumbersome. So when we talk about new search experience, what we're talking about is a scenario where is a solution where you allow the person to type in a free text and you crunch the data for your customers, bring them an experience of the key phrases and everything coming on the left, so that they can filter the data based on the search, not really filter irrelevant data because the filter combinations may be incorrect. Now in this scenario, for example, on the left hand side, we have a coupler searched and we bring the key phrases that are relevant to coupler. Now, on the right-hand side is MSDN search, which has facets and highlights the word that were found in the search based on the text that user has input. So when you bring this experience to the users, what happens is the user experience improves and they have that they get the right information pretty fast than fiddling with some of the filters which may turn out to be wrong. So what exactly is cognitive search? It is a search as a service. It allows you as developers to incorporate great search experiences into your apps. You don't need to be a search expert. You don't need to really understand the nuances of how the algorithms behind the search work. But what you get is a complete search as a service experience for your application. So you can build sophisticated search experiences. You can reduce the friction between the complexity and the right results, and you can differentiate your application. So this is one way to do, searching your backend databases and backend stuff. What becomes interesting is also the capability that you can integrate this along with some of the cognitive services. So if I take a step back, on the left-hand side, what you see here is a set of search documents that have come. Now, earlier we would have to search within the metadata of a document, but with this concept, with cognitive search and the cognitive APIs, what you can now do is take a step forward and have search within the document. So instead of relying on the metadata created or entered by an end user manually, you can now rely on search being able to really scan your documents, whether it's a document, a PPT or a PDF or anything, being able to extract a transcript of it and keep it into its store so that when the next query comes, it's also able to suggest documents which are having that same text. Good. So when we talk about search and we talk about developers, what comes to our scenario, what comes to mind is how do the developers access this? Now, the easiest way to access search is through HTTP or JSON APIs. It allows you to do everything, starting from managing search to searching the documents. It allows you to do highlighting, to do grouping or faceting or keyword or phrasing. Also allows you to do autocompletes. So from generating autocomplete from your data to showing results, to highlighting the data into the results, all those things it can be tackled into a single API call. What's more important is that while I'm talking about SQL databases and all, it can also integrate with external sources. It doesn't need to be SQL. It could be any data source. You can find any data source to plug it into Azure Search and generate the data out of it. Now, often when we go to some of the websites, especially the e-commerce websites, when there are promotions going on, we see the promotion promoted items or advertisements or all those things can actually get bumped up. So you're searching the same content, but now you're boosting the results of a particular search by using the concept of scoring profiles. Which means that, for example, if you're launching any new scheme into your enterprise app or a e-commerce platform, you can say that this particular search results that match the name and the model and all those things have to be bumped up for next 2 days. So exact searches would suddenly bump up. There's another scenario as well. On some of the websites, we say, show me results that are best match, or show me relevant results, or show me just everything. And you see that the behavior of the search completely changes. So we'll see that in today's demo, how that behavior can be accomplished with your own data set. So we have talked about some of the common usages: e-commerce catalogs, user-generated content, and line of business applications. Different things, different scenarios use different features of search. It's the same search APIs, same search SDKs that allow you to address all these scenarios. Now, if you are a .NET developer or a Java developer, you have some SDKs that you can use as well, apart from the REST APIs. And then that can help you enable search into your enterprise application. Now let's step forward and understand, how do we use search? Why we use search is clear. How do we really configure search? So step one is that we provision the service. Go to the portal, go to the APIs, go use ARM templates or use Postman REST calls, whatever works out for you to provision the service. You can enable replica so that you can have the same faster service available geographically. You can have partitions so that you can get more throughput, and all those things can be configured all through the REST APIs. The next is to actually create an index. Now think of index as a container of data. Now you have tables, you have views in SQL, you have documents in some store, you have some flat files, or you have different data sources. But think of it as a container for your data. You collect data into this container. This is called an index. So what does it usually have? A container would have fields. Fields would have names, types, and keys. Very much similar to what we have in any SQL database. You have a name, type, and key. Now names are friendly names of the fields that you want. Types are typical types that allow you, and keys are the keys that can help you use that data, or say that this is the primary, or this is the unique key of that data set. But each field now has also some additional attributes, things that change the behavior of Azure Search. For example, if I'm searching a catalog of items, it would have at least a name and a description of an item. Now, when a user types the name in the search bar, do you really search the name, or do you really search the description? Is something that is defined by the field attributes. There could also be a scenario where you are allowing the end user to type in any language of their choice, and then the linguistic and the cognitive services kick in, where they translate the text for you, or they understand that this is a singular versus a plural, and you're also able to search for that. So you're not really doing a strict search. You're using the linguistic features of Leucine or Microsoft Analyzers to help you with getting the right results back for your users. After you've created the index, the next is to really index the data. Now there are two ways: push and pull. When you say push, you're actually sending the documents to search. You're not really reaching out to the backend database or store or whatever data store it is. You're writing an intermediate service that takes the data from somewhere and then pushes back to search. This is very good in scenarios where you don't want search to have direct access to your backend databases or backend systems. The other way is the inbuilt out-of-the-box available capabilities that allow using indexers. Now, indexers are a way of pulling data, detecting the change in the data. So there could be delta changes into your data over a period of time. And indexers are able to detect those changes. If there's soft delete, understand this is a soft delete, and then push the data into the Azure Storage. And the last step is actually very simple. Use the data. Whether you want to use the data with simple operations like plus, minus, whatever, simple text queries, or use a client-server communication, whichever way it works, all these things are possible with a click of button into the search engine. Now let's quickly go through some of the demos using Azure Search Indexer with Azure SQL Database. So over here, you're seeing a database that I have provisioned. This is the AdventureWorks database, and it is a database that gets provisioned from a Azure portal when you're provisioning a SQL with a sample data. So if I click on the products and select top 1000, all right, let's try this way. It brings in all the product data. So this is a pre-populated database that get when we apply the AdventureWorks. And I request everyone else, please go on mute. Thank you so much. Now what we'll do is we'll use this database into and bring that data back into the search. If you go to the database on Azure portal, you can see a lot of options over here. And let's select this as a server, and I can go to the databases, and I select one of the database, the AdventureWorks database, and you see an option here to say Azure Search. Now remember, whatever I'm doing on the portal can be done through the REST APIs, and I'll probably show some of them to you. So over here, I see a search which is already provisioned. I can click the search and say connect to your data. It will validate the search and bring me back to the Azure database. I can give it a name, Azure SQL, which is a data source, and I can give the connection. And as soon as I establish that connection, I get all the table views over here. I get the tables and the views both included over here. Now I search for product. So I can select the product table. I can select a view that combines multiple tables and brings the results back to us. I can create next, and if you see, it's sampling the data source, which means now it is finding out what the scheme of the table is. And it then brings back if I have to attach any service. If I have new cognitive services, I can add it to here. If I want any enrichment here, translate the text, detect the language, extract key phrases, I just need to click the button and provide the source field, source data field, that which field I want to apply that analytics or enrichment on. And then I can click next. So I'll keep that aside. You can try this out. It works fantastic. And I go to the next step of creating a new index. I'll give this as AD products index. The key is product. Now this is where all these fields that were there in the table have been populated for me into the Azure portal. And I need to take a decision on what fields do I need to retrieve, filter, sort, and group when I'm searching for allowing users to search for this data. So let's just say everything is retrievable. Everything could be filterable, sortable. In the search, I just want the name and maybe the color. I expect people to size can be searched. I expect them. Yeah, that should be fine enough for me. Facetable is the search items that appear on the screen on the left-hand side to allow them to do filters and create facets. So typically, I would want a the product name maybe to be facetable. I think that should be sufficient for me. And when I create an indexer, or we can have the colors as well. Let's use the colors as well. And then we say we can create an indexer next. But what we want to also do is allow that autocomplete feature into the into the portal or into the search experience. So what we'll do is we'll select the search mode. We'll give a name to auto suggest. You can give any friendly name you want, and click on the suggester on certain things. I just want the name and maybe just the name to appear in the auto suggest, or things to be searched for auto suggest. And what I do next is create an indexer. As an indexer, I have an option to say I want to run once, I want to run every hour, I want to run daily, I want to have my own custom values. And when the data changes, I want this to be refreshed. So I can find a modified date and say, monitor the modified date. So as soon as the modified date column changes, the new data will get ingested. And all I need to do is click on submit. So every 1 hour, the indexer will try to pull the data out of my database, check for modified date, and if there are any new changes that have occurred into the data, it will bring it back to the Azure Search experience. So if I go back to the Azure Search now, and I look at the indexers, I can see there's an indexer that's in progress. And it has brought back a few records for us, 295 records for us. So if I take a step back, go into the indexes, which will show me the search results, and I go into the products index, and I just hit the search button. Let's go back. I think it's still refreshing. Yep, and it brings back all the search results for me. Now I can search over here and say bike products that have bike, and it will bring all the products that have the bike in the name or the color and all those things. Now, point to note here is you get a search score, which indicates the confidence level of search to show you the results of that particular thing. So if you see it's all in descending order, we get all the products from the back database without hitting actually the database. And this is a REST API call, so you can use the same call to enable it. At the back you can have the scoring profiles, something that I briefly talked about. You can create your own scoring profile and add new fields to say what value is more. Is it the name, is this color, or the size? Where do we really have to search? And give individual weightages to that. We're not going to do all these things in this demo, but one of the important things that I want to show you is let's enable cores so you can do the client-side searches as well. We'll save this. And one of my favorite features, something that we didn't have some time ago, I think over a year ago, is this Create Search app. So if developers had to write code from scratch to be able to use the search feature, but I can do one quick click and say the thumbnail is a thumbnail file name, title is the name, description is let's just say we'll just say product number for now. I can go into the sidebar and say, yeah, I want name and color to be sorted, and I want suggestions to appear with name, not the product ID. And all I need to do is create this search app. It will download an HTML page for me. And as soon as I open the page and I click hit, it brings back the same results on the website. I can use the same search here. I can search for the bike. You see the auto search came back. You can obviously change the HTML code to do the way you want. And you see the filters and everything changes based on the user that has searched. You can also, if I just write a bike, you can see there are 2 white bikes. But if I just do a line search, you see there are different colors. So I know there's no black bike or red bike or silver bike or yellow bike. So you can change the things based on the number of results and all those things. So this is something which comes out of the box into the Azure Search. As a developer, I particularly like the REST APIs because it gives me a bit more flexibility in achieving the results that I want. So let's bring in the Postman. So this collection that I'm sharing right now is available on GitHub, and I'm using one of the other indexers that I had set up. Quick walkthrough: search name, the endpoint of the search, indexes, the index name, and then you search for the appropriate text over here. So I can click a sleeve and try to find what kind of sleeves are there, and it will bring me all sleeves. What I was talking about earlier is cognitive search. And you can see the description. You can actually apply cognitive translation services to translate this into English and search in that. Another thing to note is, let's go through this one. You can also have things like a star or other regular expressions to allow anything that starts. It's not actual sleeve, but it starts with SLEE. It can bring back other results as well. Now, if you look at this, one of the problems we had in SQL is when we do a query to the SQL database, we have numerous records that probably match our search, and we had to do some records. We need to know the count of total records and then show it in an ASP.NET page or a JavaScript-based grid showing the actual number of records, but showing only the top 10 or top 20, and then let the user navigate through that. What happens here is it allows you to provide you the total count, and then you can define that I want at how many records. So if I go to this sample, I'm searching for the example road. I'm seeing the query type is simple, get me the top 10, let's skip 0. So it gives me the first 10 records. But if you see here, I have 113 records in total. So what I could build as an experience is I can say when I go to the next page, skip 10 and show me the 10. Now just look at this part. The confidence score is 1.8 and product ID is 770. When I go next, the confidence score reduces, the next best match goes in. When I go to the second page, I can change the skip to 20 and go back to the next page. So this improves the search experience. And also if you look at the time to search is 37 milliseconds. So the speed, the agility, the ease of programming radically increases. That said, when you have complex filters, you can also have scenarios where you're allowing the user to add symbols like plus and minuses to say road which is black or road which is not black with a minus sign. So that would ensure that you get the search results which has both road and black. There is another way. For example, your user profile says the user doesn't understand English and has a particular language it understands. You can, and if you're capturing the culture of the products, you can actually do a filter and say where a particular field is having this value, show only that result. So it's a road which is black and the culture is this. Then when you hit a send, it will bring back the cultures that match the example. Now, if I add a 1 into this and I do a search, it brings no result. So it kind of allows you to do both free text search as well as specific filters that are required for your application. But what about the left-hand side color that we saw over here? What about these facets that we are seeing over here? The other way to do is add a facet just as a parameter to the query with the things that you want to show in the facet. So it's a minor change, just adding the facet over here. And when I click the send, if you notice, what I get here is the facets and the count. So it very quickly provides us the information of the data and the facets available based on a particular query, and also gives us the total count of the search results. Now, just see how much time did it take to bring back the results from that data set. We briefly talked about scoring profile. You can provide a scoring profile here and do either a best match or a description-based match, and you can see the difference. So if I click on sending, which is doing a description-based match, you can see 991 or 796, which comes at the second step over here. If you look at this part of the search result, and when I just flip it back to do the best match, the same 796 should come back at the top. So you can see how scoring profiles can impact your search results. This is a way you can actually do a bit of tuning into your search, finding out what's the best results. How do I really make the best results available to my end users? The last thing into this part of the demo is highlighting. Going back to what I showed in the MSDN post, you can do a pre-highlighting. So I'm adding a pre-tag and a post tag. So I can do a pre-tag of bold and end with the bold into description and name. So as soon as I hit a send, it automatically adds the HTML tags that you want to be able to show the results in bold. So instead of applying any different CSS or anything, you can all add it to the search query and let Azure Search handle it for you. And this is one of the scenarios that is most likely used with a simple data set like an SQL or Cosmos or Blob. I'll take you through another scenario as well. But before we go there, remember I told you that we can do certain set of things on Azure Portal. Same things can be done on this instance using the Postman scripts or the REST APIs. I can create a complete data source, providing the SQL connection and the view through a JSON post to the Azure Search REST APIs. I can create the indexer after my index is created. In the same way, I am providing the name of the indexer, the data source, the target index, frequency at which it has to search, retry attempts, and all those things I can add here. I can also create an index. So the complex screen that had different fields and their attributes like facetable, searchable, and all those things can be brought in here. So you can use different models, and if you're not comfortable with using this, you can also go back to the portal, back into the search experience on the portal, and you can click on the index definition. So you can create on the portal and then extract the JSON file, and then use the Postman or ARM templates or whatever way works out to provision these things. Let's go back to presentation and validate whether we are going on track, and we have covered most of the things. We did see how an indexer frequency and the refresh columns can be configured. We saw how suggest and cognitive skills can be added into the search index. We saw how the facets work and how it can be used to get the data back from the backend. We saw a bit around the scoring profiles. One thing that we did not touch is the weightage. So you can change the functions and say boost for 1 day based on the modified date. So if the item is recently modified, you can see it on the top. There are different functions that you can apply over there. And when you use the scoring profiles, you get the same results at a different level. I mean, sometimes it may come at the top to product, sometimes it can go down based on the scoring profile. We saw how an auto suggest worked, and that would complete a front-end experience of a particular use case, which is mostly used in e-commerce or enterprise applications. Now we'll go to the second demo. But before we go there, we'll quickly walk through what is indexing in a different kind of world, it's a relatively complex world. So what we built here, and this is one of the other repos that I've shared earlier, is a web crawler that gets the data of your on-prem website, let's say, and also media files from that website, and then puts both of them into a different data sources in Azure Search. So basically what you're doing is you're collecting information from multiple places, whether it's media files or SQLs, or maybe 2 SQLs, 2 media files, doesn't matter, but there are 2 different data sources of 2 different types of nature. And what it does is creates indexers for both of them. So one of them would go and retrieve the data from the SQL using a query or whatever, or a view. And second one is actually, in this case, is scanning the blobs. So my media files go onto the blob, and my relational data goes onto SQL. And there's an indexer, there are 2 indexers that will pull the data out of these 2 sources. Now, if your data doesn't support a pull, you can still use the push-based mechanism. It's just the frequency at which the push and the pull happens may be different. So you can try to synchronize it if required, or you can have different frequencies. Azure Search is okay with both of them. And at the end, at the heart of it, is the index. And index is where the magic happens. What it does is it combines the 2 indexer data, brings back the data into one single index so that you're not really searching to different data sources. So let's take a look at the final demo for this presentation. So this is the GitHub repository, which has the scripts to deploy the Azure Search completely in PowerShell, taking your data sources, your indexers, and index into place and deploying them from scratch. This is a .NET source code. which is using a scrolling a website and then putting data into both the storage as well as into the database based on the nature of data. So if I go back into my search experience, I can see there are two indexes over here. There is a blob and there is a SQL indexer that ran 3 minutes ago. There are two data sources for that. One is retrieving the blob storage, and second is from the SQL. It's a completely new SQL. And there is one index over here, which is getting 397 documents. So I can again fire up my Search Explorer, this time change the index to this, and just say Azure. For this demo, I've scrolled my own website. So you can see the content coming up here. You can see the metadata from the SQL that came up into this post. And this content is actually from the HTML files. So basically, it allows you to crawl, search. The crawler allows you to crawl and then have a search, intelligent search on top of it. So you can use highlights and all those things on your enterprise application or enterprise websites as well. Even if they're not having SQL databases, you can still enable that kind of search functionality. The interesting thing about this, let me take a step back and go into the storage part of it. So if I go to the storage and I go to the containers, I see a search container. And let's click one of them. You see, this is the HTML page that gets stripped and added into this, but there are document files for which there are cognitive services that can be applied on them to search for the text that we have. So in a nutshell, Azure Search is pretty powerful. It allows you to it allows you to search for things that are within your databases, brings back the content into your to the users in a friendly way, and allows them to have a friction-free search, scaling out easily and see the data that's relevant to them. So let's recap what we saw earlier, and then we'll open up for questions. So as an overview again, we built a sophisticated search experience with few clicks or few configurations. As you saw, we kind of helped the end users access the search capability, like you see in the search websites, top search websites or top e-commerce web platforms. Bring that back into a common database or a common file storage or different data sources that you have, and then allow them to not fiddle with the filters, which are irrelevant, and search what's really required. With that, I would like to conclude the session and open up for any questions.